Oh, it's bright. Okay. Hello, everyone. Welcome to my presentation about RubyGems security. A bit about me. I specialize in supply chain. I work for a company called Mend. I'm part of the RubyGems security team, an active open source contributor, and a creator of Karavka framework. You may know me from this button here. If you click it, you're going to get a nice diff of every single release of every single package in RubyGems. So I built that. And surprisingly, we're going to talk for a second about that. It's already fixed, so don't worry. It's quite interesting, right? What a coincidence. RubyGems is not malicious, at least not all of it. Someone reported us to Google because of one of the packages. The package is called Metasploit Payloads, and we know about it. It contains test signatures for antivirus software, so someone was probably just scanning packages and reported that. It's not malicious. Though your systems could be affected because it was not only the website, it was, there are those lists for ad blockers. And if you would have a system that would block domains on the DNS level, you wouldn't be able to run bundle install. But luckily, folks from Google fixed that like 2 minutes ago. So let's get back to the main agenda here. I'm going to do a really quick introduction to the supply chain. I'm going to talk about the most recent critical incidents we had in RubyGems and what we did to mitigate them and what countermeasures are we taking. Please keep in mind that your security is your responsibility. We do as much as we can, but in the end, you shouldn't fully trust anyone. There's so many things happening in RubyGems in regards to security that, we could sit here for a whole day. So I'm just going to talk about what I do within the scope of RubyGems operations. So open source supply chain is quite simple. Some people have packages that they want to share, and there are people that just want to, use them. And this is the most common idea about what open source supply chain is. It's actually more complex. We're not going to go into details, but what you need to keep in mind is that registries tend to say that packages are immutable, which means that if you upload a version 1.1.0, if you download it today, it's going to be the same if you download it in two weeks. That's not always true. Unfortunately, people abuse certain capabilities in RubyGems and in other registries like npm or PyPy to achieve auto-updating software. It's a really bad practice, but people do that. And we need to deal with this as well. For us, it's all about RubyGems. I crunched some quite interesting stats. So every second of my talk, there are 162 lines of content being released to RubyGems. That's quite a lot of changes, if you think about it. Every 3 minutes, we get a new package version, a lot of downloads, and a lot of users. And if you convert that into a stream of messages, this is how it looks in, I would say, real time. So pretty much, constant stream of code, comments, binary data. It's like happening non-stop every single day. And you need to keep in mind that most of your apps aren't actually yours. They're built on top of blocks, and so on. That's why it's a really good thing for malicious actors to target open source supply chain to try to get into companies. And if you think about the source origin of attacks, there are actually only two types. There are the internal ones, when the legit owners of packages do something with them. Either they're frustrated or just tired or something. And there are external malicious actors that want to take over packages or get into registries like RubyGems. And yeah, some malicious actors target users, our users, or their gems. And some of them target the platform itself, right? If you were able to exploit the platform, obviously you will be much more successful. But it's also, luckily for us, much harder. And keeping that in mind, there are a couple really interesting things that happened in RubyGems a couple months ago. Critical ones. We had to issue critical severities on those. Yeah, and as you can see, unauthorized package takeover. That sounds really bad, and it was. We had a bug in the code of RubyGems, pretty much allowing you to build a different package that would allow you to take ownership of other packages. You could basically remove versions of packages you didn't own. And that was really bad, because not only you could remove them, which is by itself quite problematic, you could replace those packages with your own malicious content. So that isn't a problem, right? Because package versions are immutable. So, if you remove it, you shouldn't be able, first of all, you shouldn't be able to upload the same version to RubyGems. That's like one of the primary things we do. If you remove a version, you need to release a new one that is of a different version, right? And second of all, they're supposed to be immutable, so all good. Not really. What majority of people don't know is that package versions are immutable within the scope of the platform for which they're designed. And the default platform for RubyGems, for Ruby, is called Ruby. But there are other platforms based on a CPU type, for example. So that was exploited. You could remove the Ruby, let's say a package called 1.1.0 dedicated for Ruby. You could remove that and upload a CPU-specific packages with the same number, right? It wouldn't violate limitations of RubyGems platform. But that's not a problem, because you have a log file, right? Yes, you do. We do. But if you don't run, if you have a log file and you don't run it with the ---- frozen, bundlers sometimes can actually resolve dependencies again, even if you run it on production, where you wouldn't expect, because you would expect reproducibility of bundler install execution. No, edge cases, right? So this is what happened. But we got really scared when that happened, because we went with this assumption that, okay, we got this report from a bug bounty program, but we need to make an assumption that someone might have discovered that and exploited that for malicious reasons without reporting that to us before, right? We couldn't go with the assumption that, oh yeah, it was discovered now. But what was really good about this is that the takeover of a package using this particular bug had to transfer the ownership, right? To get an ownership of a package, you would have to yank all of the versions. Then under certain circumstances, the name would be open, and you could take it over. And this is not how normal ownership giveaway works. You invite someone to RubyGems, you give them access to your package, and for a brief amount of time, there are two owners, right? And then you kind of sign yourself out of it. So there's a new owner. But if it was a malicious activity, there would be a direct jump to the new owner without this intermediate phase. And this is what we used to check if this was exploited before. We picked all of the packages from last year with any state change, and a state change means a new release or a yanked release. We picked those with ownership changes, and then we picked those with hyphen because this was the requirement for this exploit to work. The package had to have a name with a hyphen. And then we would pick only those that would have a specific platform releases in it. So we found 3 packages. Luckily for us, they were all only research packages. But you know, it was a kind of critical one, so we wanted to dive deeper into that. So we tried to find all of the packages that would have the Ruby platform package removed, but it would also still have other platform-specific versions present. We found 85 like this. Again, we reduced it to the ones with hyphens, and we checked them manually, each of them, to make sure that they don't contain malicious content. Hooray, right? So yeah, it was a hard couple days for us. And then we went with this assumption, hey, maybe we could do something to make sure that if our bucket would be compromised, for example, and the content would be replaced, that we would know about it, right? We built something independent exactly for that case, an external system where we check in RubyGems once in a while all of the packages. We compare their hashes, and then if everything is fine, you know, we just keep it in a loop. If something would go wrong, we get a notification, we pick it up, and we check what is happening, right? And we're really happy about it. And then 2 weeks later, we got another report, another critical one. There was a beautiful one, actually. And you're going to see in a second why it's so beautiful, because like all of the things that we did, we could just throw into trash. So again, we had a bug in RubyGems. And the bug was quite simple. If you would try to release a gem version, it has some metadata. We validate this. But prior to the validation, we actually stored the artifact, which is the gem itself, a packed gem, in S3. Then we run validations. And this security researcher was able to cause our validations to actually crash, to give 500. But the artifact would be still stored in S3, which means it would be accessible, right? Well, this shouldn't be a problem because the version wasn't released. First of all, because the attacker didn't have permissions to release it. And second of all, because there was no record. There was 500, transaction was rolled back, right? So if you would go to RubyGems website, you wouldn't see this version. So no problem there, right? Unfortunately, there could be a new release later on, but the malicious content was already in S3, which means you could hit Fastly, and Fastly would cache this malicious package version. Yes, later on there would be a alleged release that would override the content in RubyGems. So it would override the content in S3, but it wouldn't purge the caches in Fastly. And it's beautiful. You know why? Because a malicious actor could preheat caches only in certain areas of the world, right? So let's say he or she would be targeting Japanese companies. And this actor could preheat only Fastly nodes from Japan. And you know, we were operating in US, and our beautiful system was making queries to Fastly from US, right? So our caches, we would never notice those malicious packages. We would have to basically ping every single node of Fastly to make sure that it's legit. A beautiful one. So how do you run a risk assessment on something like that? How do you make sure that we have a healthy and stable ecosystem and that it wasn't exploited in any ways? So first of all, there was again the requirement of having a platform. So we run checks. The package had to crash RubyGems API, so we had to have a record of in our backtracker. And we found only one package. There would be non-research one that would go through this whole cycle. We checked it. It was a legit one. It was just like a coincidence that it caused the same things. But we weren't happy about it, about our assessment. We weren't fully happy about our assessment because we had to go with this assumption that there may still be packages in S3 that are there, whether because of this bug or some sort of different similar one, that would contain code for not yet released legit versions, right? So how do you deal with this? We downloaded all of our data from S3. We correlated this data, and we checked how many of the S3 files correspond to not yet released or non-existing versions. We picked the ones that were platformed, and we checked the recent ones. We had a couple of them. I think there was like 20 of them, really old ones, and they were related to a different bug, where upon young, we wouldn't remove some of the artifacts, so it was like irrelevant from the security standpoint. We checked that, and it was okay. But it was okay for us, for RubyGems. But now the question is, what about people that actually might have downloaded something like this? How do we make sure that you guys are safe, right? We validated that we don't have this problem in RubyGems anymore. We purged all of the Fastly caches. So we still wanted to make sure that everyone is safe. Yeah, again, packages immutability, not per platform. Bundler has checksum verification, right? But sometimes it doesn't work. So there are edge cases, it's a backwards compatibility legacy. We had to go with this assumption that something could have just gone wrong with the checksum verification. So we built a small tool called Bundler Integrity that you can still use. What it basically does, it just checks directly with RubyGems, bypassing the Fastly, for the proper checksums of all of the artifacts. You can export them to a text file, and you can just check it against your production or any other place. You can put it in a CI/CD to make sure that your artifacts are not in any way changed. From RubyGems to your servers, that nothing happened in between, right? And yeah, again, we're happy. Criticals, 2 criticals in a month. Yeah, that's not the best month for us. But not everything gets a CVE assigned. We see a lot of activities around brandjacking. So brandjacking is a really simple way of releasing packages that other people think that they contain certain code, but they don't. It just leverages inconsistent namings and other things. Big companies tend to have one repository for all of their languages, for giving SDKs and so on. And you can guess who owns this gem. And there's going to be a small hint, it's not Google. Or this one. It's not AWS. And not Google. And this one. And I could go on, I have thousands of them, so they're mine. But what is interesting about brandjacking, that it's really simple because RubyGems provides a lot of APIs that you can use to data mine. So you can spend a day and get a lot of potential candidates that you can use to automate a really big attack. And we actually encourage that. We used to, we changed that. But if you would run, I think gem new or gem create, I don't remember the command. If you create a new gem, it creates a README. And this README contains those lines. Bundle add or run gem install. But the problem is, quite often people start their gem, and they don't release immediately the code to RubyGems. So this name is someone else's, right? It's empty, it's not being used. And malicious actors actually monitor GitHub in real time. They pick up those lines, and they automatically take over this name. So people, they may not want to release the gem to RubyGems, but still there's a recommendation bundle add or gem install, not take it from GitHub. And this is being exploited quite a lot. So we changed the template with a long message. Please put here name and block it when you decide to release to RubyGems. And we quite often block many packages a week that contain tracing code, coin mining, and stuff like that. People make mistakes, right? And a good ecosystem should keep that in mind. People forget to pay for their domains. They expire. When that happens, their RubyGems account don't. And this actually works. We've seen that being used, both in RubyGems and NPM. You can get users' domains. You can just monitor them. We did implement a system that is automatically locking the accounts 1 day before the domain expires. Because the assumption is, OK, if you will probably pay for your domain a couple weeks in advance, if you care about it. If you forgot about it, then it's just better to lock the account. And at worst case, there's going to be some manual work on our side. There's going to be an issue raised through Zendesk, and we're just going to unblock it ourselves. So I've seen an article about NPM, how I got access to this 100 million downloads package. And we were sitting on Slack with the other team members. It's like, yeah, we have a protection for at least a year now. So please keep in mind that open source is a great way to get into a company's supply chain. It's really easy. There are a lot of things happening on a daily basis. No one reads the code. We do. All 162 lines a second. We actually scan them. Keep in mind, you have dependencies, but also your dependencies have dependencies. And those dependencies have dependencies, and it's called dependency hell for a reason. And keep in mind that it's not always about getting access to your production. We've seen a lot of packages. I've seen a lot of packages both in RubyGems and in NPM and PyPy, where the primary goal would be to steal environment credentials, .env, SSH keys, and other things, just to get potential access to other things later. Usually this is being stolen, packages being removed after a week or two when attacker has enough, a big enough sample, right? And you may not know about it. You've installed it once, this package didn't work, it's no longer there. Well, user removed it, right? You didn't do any due diligence to make sure that everything is as expected. You go on with your life, and then suddenly in a month, someone pushes something to your AWS, right? You're using those keys or GitHub. So it's worth keeping that in mind, that there's this shift left movement in security. There's also shift left movement in malicious actors' activities. It's much harder to get into production. Still doable, but much harder. It's easier to target software developers' machines because they're quite often not as well as protected as production systems. But potential risks to an organization are almost as big, right? Access to the source code, access to cloud providers, SSH keys, all of that things that you have on your laptop can be basically stolen in a second. And I know that because I did that. So this is actually taken one of the malicious packages. Single line, right? And you have a really big problem. And you just need to install a package. You don't have to run it. And actor can do whatever he wants. And it is really worth keeping in mind that running bundle add, bundle install, by running that, you give away permissions to your computer, all of it. It's like, here you go, Maciej, I want to use your open source, here's my computer. Do whatever you want with it, right? We go with this trust by default approach to open source, but RubyGems is not an app store, technically speaking. It's a space to share code, but it's not an app store. So the end responsibility is on you. As I said, there are 162 lines of changes every second, every day, every hour, like on average, obviously, right? But luckily for us, there are only 6 lines of additions. Because you don't release only changes to your packages, you release the whole packages. So we compute the diffs, and we know what was changed, right? And that makes it much easier for us to inspect the code because the number of changed lines is most of the time much smaller than the number of all of the lines that are released. So trust no one. Please watch the RubyGems announcements. Because we try to be really public about what we do and what is happening. If there are any critical things, we'll definitely notify the community. Run CI/CD in isolated stages. Use Docker for development, because then even if you install by accident a malicious package, it shouldn't steal your environment credentials. And you can look at the offering of the company I work in, because we provide a lot of tools for supply chain and other things related to security. Thank you.